Lab 4 oscillations. So the lab overview and results. The objective of this lab was to compare predicted motion from GlowScript with the observed motion from Tracker. We will compare position graphs, but we will also analyze an energy graph. Results. So my position data in the X direction for both observed and predicted data are nearly identical, but in the Y direction, the data does vary, but there are still some similarities. Overall, the change in total energy is 0, meaning that the energy principle is satisfied. Here are some equations. We have Newton's second law involving momentum. It's just the F net is equal to change in P over change in T. In this case, it would be the F of spring versus F of gravity. So the energy principle, we have the change in energy of the system is equal to the work done by the surroundings, N plus Q. But in this case, we're going to have the change in kinetic plus the change in the spring potential and the change in gravitational potential are going to be equal to 0. We have the velocity update formula, which is the V final equals V initial plus F net over M delta T. Position update formula, we're going to be using that. We're going to have R final equals R initial plus V average change in T. We're going to be using kinetic energy, which is 1/2 mv squared. We're going to have the spring force, which is K times L minus L naught times L hat. We have gravitational potential energy, which is mgh, and then spring potential energy, which is 1/2 ks squared, s being L minus L hat. So Tracker. I put this through Tracker, the video of the spring. Important info to notice that the relaxed length of the spring is 0.123. We have K being 6.83. The mass of the spring, or the mass of the mass is 0.402, and then the object tracking began from the point the spring was released from the hand, so it started at rest. You just cannot see that in the screenshot here, but it did begin at rest. And then we have the graphs, as you can see in the X and Y direction, it is oscillating. Now we have the GlowScript code. I highlighted some very important information that I had to type in. We have the gravity, Ks, L naught, which, like I said, was 1.123 and 6.83, and then we had to type in L and L hat and the S, and then K, UG, US, E, which we have defined before. We know that E is just the K plus UG plus US, which is kinetic and gravitational and the spring energy potential, and then US is equal to 1/2 ks squared. And then here we have all the variables that we've defined. So K, UG, US, E. We have the gravity vector, which we know that it should be negative in the Y direction. We have the spring force and then the net force. So the force of the spring plus the force of gravity. And then we have the velocity update formula, the position update formula. We have calculated L, L hat, and S. And then down here we have K. We have K, UG, US, and E, but we also have the change in those values, which is what delta K, delta UG, delta US, and delta E stand for. So here are the GlowScript models once that code is typed in. So as you can see, the Y position does vary a lot. In the X, as you can see here, the observed versus the predicted are basically on top of each other. They're very, very close. In the Y direction, that is not the case. I did try and fix this multiple times. It actually got worse each time I tried to fix it, but there are similarities, as in the fact that both the observed and the predicted dip and peak at the same time. So some errors is I might not have gotten the point mass correct each time when I was tracking it. This system is overall not a closed system, so there's going to be outside forces acting on the system, but it's more, like I said, it's more important to note that the data in the Y section dips and peaks at the same time, meaning that there is some similarity. And as we can see down here, the energy graph shows that the change in energy is 0, which is about to answer our next question. What does it mean? So for your model system, is the energy principle satisfied? It is, because I highlighted here that delta E is 0, meaning that we have satisfied the energy principle by looking at this graph, which once again we found after we typed in all of the information on GlowScript. So what does it mean? Using the data you obtain in Tracker, make 2 separate estimates of oscillation periods. So we have the X position and then the Y position data. So the T in the X is equal to 0.519 seconds, and then the T in the Y is equal to 0.485 seconds. And so we have different values. So obviously having different values is we're going to have different values for different calculations, like K and such. But there's also some reasons why these periods are different. It could just be external forces acting on the system, like drag and air resistance, things that we don't always take into account. But that concludes this video. Thank you so much for watching.